Hello everybody, it's Callum at Repair Wins, and in the video today I'm going to be doing something a little bit different. So I've got a motherboard here from a Sony VAIO laptop. I've put a quad-core 8-thread i7 CPU in there, and the reason why I've done that is that I'd like to turn it into an all-in-one. I've also got a sheet of MDF, I've got the USB ports and the charging port and so on. I've added this bit of ribbon cable so I can connect those up. And I've got 16 gigs of RAM. This is all spare stuff that I had, with the exception of the ribbon cable. So I thought, why don't I take these parts, fashion them all together, and then turn them into a panel, that can be screwed to the back of this rubbish monitor, just for testing. And if you actually wanted to use this as a better machine, because a 4-core 8-thread i7 is still actually fairly capable, even in 2026, not 2025 anymore, is it? Even in 2026. Then you could. The theory is you would just remove this motherboard, take the panel off, screw the panel back down to a new monitor, screw the board on. But I think this could be a really interesting project because there's a lot of little sort of things I need to do. I need to drill holes in the board, I need to work out where's best to mount this and how to mount it. I need to make sure I'm going to disable the GPU because the GPU is not prone to fail, but I've got quite a powerful CPU in here. And the dedicated graphics on such an old board are so rubbish anyway that you don't need them. They just slurp up power needlessly. So we've got to disable the GPU by removing this coil. Probably do some fresh thermal paste. I've got to install the RAM. We've got to figure out how to put all of this stuff down on that MDF board. Then we need to get an SSD installed and get an OS installed and so on. So it's going to be quite long-winded, but I aim to do it in one episode. So without any further ado, I'm just going to stop talking and let's get started. The first thing to do, mainly because it's so quick and so easy, is just to install the RAM. To install RAM, it's keyed, so it only goes in one way. And you can tell the difference between DDR3 and DDR4 because of where the notch is positioned. So on DDR4, the notch is closer to the middle. You also get standard DDR3 and then low voltage. This motherboard supports standard DDR3, but it'll either say PC3L or DDR3L. Because standard DDR3 DIMMs are pretty much less desirable, they're less valuable. Any motherboard that supports them you would use, but to install them here I'm literally just going to line it up at 45 degrees, push it into the slot, click it down. Do the same again. We're going to line it up at 45 degrees, press it into the slot, click it down. I've already blown this out with compressed air off camera, so that's job one done. The next thing to do is to work out where to drill the 4 holes in here, because we've got 4 holes that are 100 mil apart like this. But the thing is, you might not necessarily want to put them directly in the middle because perhaps it makes sense to have the board shifted over. Because that's going to move the ports over to one side. And I'm right-handed and so is the majority of the population. So let's assume the monitor's like this and I need to grab, say, the USB ports that are here and we pretend it's in the center. Then that is actually going to be quite good anyway. I appreciate it doesn't all fit in the frame, but I've centered the board in the middle of the monitor. And that's, do you know what, that's fine, we'll just drill the holes in the middle. That's that one sorted. I did some more measuring on the other side because it's transpired that basically I don't know how to bloody measure. That's fine though. I've got 1, 2, 3, 4 points. They're all circled, but I'm happy that if I drill that, and that, then we'll have something that can screw onto the back of the monitor. And you might notice this is slightly closer to the bottom than that one. I could pretend I did that on purpose. I didn't, but it's fine because it's actually helpful. Because I can either have it like this, or I can flip it over, and then have these points be at the top, if you see what I mean. Because this one's here, but if you flip it around, now it's going to be at the top. Anyway then, I can get the drill, I can put a 4.5mm bit in there, and I can just blast through these. Once again, the best tool in my arsenal is going to come into play. Let's just grab the chuck key, tighten it up. Now this is obviously a massive pain compared to a modern drill where you just twist, 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 done. But remember, I like old tools, and this thing didn't even cost £15, and I have more than had my money's worth out of it. This bit is now in the chuck. Just tighten it up. Boom. Right, that's not going to go anywhere. I can take the key out, put it down. Let's bring the board in. Shouldn't be more than a few minutes. Probably, well, not even a minute. Obviously, there's better ways of doing that, but I don't need to put any more holes in this desk, because if I put much more in there, it won't be usable. I've cleaned this board up. I just took a much bigger drill bit and I went around the edges to get rid of all the excess. So that's fine. And if I line it up on top of here, then fingers crossed we'll see 4 screw heads. So there's 1, there's 2, there's 3, and there's 4. Absolutely spot on. Quite hard to see on camera, but the centre of every screw is poking there. So I'm confident that that will line up if I was to take those screws out and screw the board down right now. But before we do that, we need to do some work to the board. So you can see here there's a charging connector, and I've got the charging cable, the original one, that would just plug into here, and then this connector runs off wherever it runs off. But the thing is, the wires are actually really thin and a bit flimsy. I've got a powerful CPU in here, and I only have 65 watt chargers. I want to use it with a 90 watt charger like this one, which you'll notice is made by Dell, but it shouldn't actually matter, because if you look here, there's only 4 wires, so there's 2 for ground and there's 2 for, 19 or 20 volts, but there isn't actually the middle wire, which is for the signal. So this laptop clearly never made use of the signal pin, so all we need to do is put a blob of solder at the top, a blob of solder at the bottom, and then we can connect a charging connector from an old Dell or an old HP laptop that was broken. I've already modified it, but the idea is we would be using this Dell or HP charging connector instead. I added a power switch to my soldering station, and I'm actually quite disappointed that I never turned it into a video, because I sort of recorded half, and then I went to do one thing off camera, and I got ahead of myself and just did the entire project, basically, without recording any of it. But that's a power switch from an old DVD drive there, and it's more than capable for this device. But remember, grab the spare parts that you have and just start hacking something together. Anyway, there you can see I've turned that on and the iron is running. I'm going to put some flux on the motherboard, and maybe you know by now, maybe you don't, but flux helps solder flow. So all I'm doing, and I'll bring the camera down in a minute so you can see the end result, is I'm just adding fresh solder here, because I'm going to solder some wire over the top of this. So 420 degrees is what the iron is set to, which is hot. Like, you wouldn't normally solder at this temperature, but I am trying to stick 2 pins together. There we go, big blob of solder on there, which is exactly what I want, and then we'll do here as well. There you go, big blob of solder on there. Now I can get the wires, and I'm confident enough to just do this directly over the motherboard. And there we go. Turns out it wasn't 420, it was 405. But if I bring the board up to you now, can you see what I've done? We've got those 2 solder blobs, one at the top, one at the bottom, and the middle pin has been left alone. And the idea is I'm just going to lay this down over the top of the connector, solder that, solder the other. And in order to know which way round to solder it, I'll just bend this so the ground is at the top, because that's the black wires, and the 20 volts is at the bottom. I've zoomed the camera in a good way so you can see what I'm doing. So remember, ground at the top, positive at the bottom, and I should just be able to get the iron out. Put this over, sort of put a slight bend in them. I think I want to put some flux on there and neaten that up. Just a bit more flux. I don't want to go overboard and, melt the connector, because the idea of doing it this way is that I can still reuse the old charging connector if needs be. Do you know what? That slight little bit of solder that's sticking up, that's fine. I'll just leave it like that. There is such a thing as quitting while you're ahead, so instead of trying to make that look absolutely perfect, melting the connector and destroying everything, I think we'll just have it looking good enough because we know that it's going to work. The point is, they're both nice, solid solder connections. I've got a few different boards and screws and so on in this little pot. The one that's important to us is this one. It's originally from the laptop's palm rest, so it has, I'm guessing, volume up, volume down and mute, clearly not in that order, and then a power button. So what I want to do is just plug this into here, and then we'll get a VGA monitor plugged in, and we'll plug the power in, and then we need to test if this thing works before we proceed further. All I need to do is just open this little latch. It opens up 90 degrees like a book. So you see how that's open? Close it down. So you open it up, plug your connector in, and normally it's the the bit of plastic is up at the top. Just hold it in place and then lock it shut. The way that I have all of this set up is a bit dodgy, but the power is plugged in, the VGA is plugged in, the power cable is plugged in, just using the drill to hold this in place. So if I press the power button, we should see the fan start to spin. So let's do that. And to be fair, the fan isn't spinning. Brilliant. That's not a good start. Now press it down more firmly, the fan still doesn't spin. It is definitely plugged in. And there's no output to the monitor, so I will just plug the original charger in. One moment, please. Despite checking 15 or 20 times, it feels like, I somehow managed to solder these the wrong way around. Now, luckily, modern laptops have diodes and stuff built in, so I'm absolutely confident it'll be fine. I'm just going to flip the two wires around and we'll be okay. But when you're doing something like this yourself, please just make sure you pay attention. Right, I've spun that around, so let's see. Hit the power button and the fan has come to life, so let's bring it up to the monitor. And it's switched on, operating system not found. Simple as that. Good news, it works. So the next thing to do is to disable the GPU. And you might be thinking, well, why would you disable the GPU? So the theory is we just put low melt solder on each side, heat it up, pull it off, and we're away. Chances are you may also have thought, well, if you're removing the GPU, then how's the computer going to, how's the machine going to display? And the answer is it just falls back to using the graphics inside the CPU, because most laptops don't actually have a GPU soldered to the board. I am using low melt solder here, and I think if I was a smart man I would take the RAM back out, so let's just do that. I'm going to put this thing on top of the capacitor, just so I don't dump loads of heat into it. And I'm using low melt solder because this is quite a big hefty component. I may even be able to go back and forth with the tweezers and just lift this part off the board. So let's try that. If I'm sort of pulling up, put a lot of heat into this side, and then plenty of heat into this side. I'm not in any rush here at all. I don't want to rip the pad off the board. Brilliant. That was easy enough. We don't even need the hot air. I suppose the question on everyone's minds then, will it still output without this coil? Let's go and take a look. Push the button. And good, it is still switching on. That's a good start. And this time we haven't actually got a display on the screen. I don't think that's because there's no power going to the CPU. I think it's more because the GPU is set as the default in the BIOS. And usually the way you get around it is by taking the charger out and removing the BIOS battery, because that's reset the BIOS to its defaults, so fingers crossed. So that has now switched back on again, and if we're lucky, of course, it's going to output to the screen. I ended up soldering the coil back to the motherboard, and you can see I've plugged an SSD in over there, 240 gig drive, fairly basic one. So I soldered the coil back, and that has allowed me to get into the BIOS, but unfortunately, there's nowhere in here where I can actually modify, the display device. So external device just means, will the computer boot from a USB drive or will it not? So that's really unfortunate. I think the only way I'm going to make the only way I'm going to make the laptop work without a GPU is to pretty much desolder the BIOS chip and reflash the firmware after I've modified it. But in the meantime, I thought, why don't we get Linux installed anyway, since I've soldered the coil back on, as you can see. And no, I didn't do it perfectly, I just did it quickly. And fingers crossed, if I install Linux, I can then remove the coil, and hopefully the computer will just boot straight into Linux. And then when Linux loads, it will choose the integrated graphics, and I might not even need to bother with all that work. I've chosen Ubuntu Linux. The reason for that is that this is actually a fairly powerful machine. Ubuntu is the most popular. It's it's the one that has the most support if any issues arise. So that's the reason why I've chosen Ubuntu. Let's say someone who isn't terribly tech savvy goes to use this computer. I just want to make sure it's something that they can use without too much effort. So I'm going to go through the rest of the setup process, and then when Linux is installed, the computer will boot into it automatically, and we can pick back up. Linux is now fully installed, so I'm just going to use my mouse to reboot the machine. Now that the machine's happily running, i.e. I switch it on, it boots straight into Linux with no user input. I'm going to shut it down, I'm going to remove that coil again, and we're going to see if it boots and shows the same screen. I've removed the coil, I've rebooted the machine, but it doesn't appear to be showing anything on the screen, which is quite disappointing. So I'm probably going to have to put the coil back on again, leave it in place for now, and then proceed with the rest of the project. To distract me briefly from the GPU problem, I'm going to install the panel on the back of the monitor. So I'm using 4 washers just to put a bit of space between the VAIO holes and the body of the monitor. There's 2 sides to a washer, by the way. One side is sort of matte, it's a bit coarse, and the other side's a lot smoother. So the smoother side is facing down towards the monitor. Brilliant, so that's in place, and I've just put the screws in the holes. I haven't tightened them up yet there. And in an ideal world, I would have some washers to go around those screws, but I don't have those on me at the moment, so this I'll have to do for now. I've been saved some time because it turns out I don't need to model standoffs of the motherboard. So there's a website called Thingiverse, which has a bunch of 3D models on it. There's another one called Printables. But anyway, on Thingiverse, the user Coat has uploaded this. It's a standoff for electronics, and it's customizable using something called SCAD, S-C-A-D. You can see all sort of the presets there. So I downloaded a tool called OpenSCAD. You just go to that website and you do the download. And then within OpenSCAD, I loaded up the model. The presets are here. You just change them accordingly. So let's say I want the standoff to be 50 millimeters tall, for example. So it's just really, really high up, and I hit F5. That's going to preview it. And that's obviously daft, like you would never have that. But the point is, you just go and you change all of these options. Then you hit F6 to draw the model. Ping, and then F7 to export the model. So obviously I would just export that to my computer. So that's what I've done. I've exported it. It's in my downloads folder. So if I go here, you can see customizable, yada, 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 yada. So there we go. It's loaded into Cura, and I'm now going to do the rest of the things I need to do in order to be able to print a number of these models. I've come up with a method for mounting the motherboard. So you can see I've got all these sort of posts on the bottom, and I've left 2 of them not installed so that I can show you how to put them on. But I've got 2 screws. I've got a screwdriver, and I've put a Phillips 1 bit inside. So the theory is I just put the screw through the hole. This is hardly something that needs to be shown, but the screw goes through the hole. I will then hold this piece in place very loosely. Then I get the screwdriver lined up. It's quite fiddly work, this. I'll spin it backwards for a moment just to straighten it out. There we are. And then the final one goes beside the GPU. And unfortunately, you can't disable the GPU on these Sony boards. I did a lot of research and a lot of digging. And again, that's the reason why I take these projects on, because now I've got more knowledge. Anyway, as I was saying, Sony BIOSes are supposedly hard, and even if you remove the GPU coil, and there's a chip beneath the RAM that you can take out as well, that in any other laptop would disable the graphics. On these machines, the display is routed through the GPU always, so you can't just disable it. At least that's what I could gather. But we've now got all of the posts installed on the board, so you can see it's going to sit nice and flat. But the plan is to install this board as close to this corner as I can, and it is going to go down here because the power button board is going to go there and the USB board is going to go here, so there's just enough room for everything. And then as for the SSD or the hard drive, it's going to go here and it will hang ever so slightly off, or I might just use a shorter drive or something like that. But in order to attach the board, I'm going to use super glue, which isn't normally what you would use for a job like this, but it's the only sort of adhesive I've got to hand. So the plan is just to flip this over, pretty much put super glue on every single one of these posts, flip it back, line it up, and then off we go. So the super glue is already squeezing itself out of the tube, which it has an annoying habit of doing. I don't want to take too long here, but luckily I don't need much adhesion, which is good because the bottom of this 3D printed surface is a bit bumpy because I had to print everything on a raft, and then obviously it's going into MDF, which is going to absorb the glue. So I'm putting plenty on because I've got lots of super glue and it's cheap to buy, so you wouldn't want to be stingy. And you only put the glue on one surface, by the way, you don't put the glue on both of them. So as far as I can see, all of these have glue on them, so I'm going to flip it around now without touching any of the posts. A bit like a screen protector, I'm going to do my best to line it up from above, and then when I think it's lined up, I'm going to press it down into place. Right, so that's just sat for the moment, and then the good thing is I can actually put my hands beneath and just squeeze down on the posts. And for the ones where I can't squeeze down, I just press on the screw heads. Cool, so I spent 5 minutes recording that clip and 4 minutes running around like an idiot looking for glue. So the reality is, if you were doing this yourself, it would only take you sort of 2.5 minutes to get a board like this glued in place. This is going to sit exactly where it is now for sort of 8 hours. I want to be absolutely sure the glue has fully adhered itself down, but you know, this has got the trappings of a computer now. It's a board mounted to a monitor anyway. I appreciate this is only just in frame, but you can see that I've installed the VGA cable, and you'll be seeing more of that later. I've gotten the USB board, and like I did earlier, I've put 3 posts on the bottom. So you can see now that's good. I was going to put it about here, but if the hard drive is in the way, then that's obviously not going to work. but I should just about be able to get this plugged in, lock the latch down, and then sort of, I mean, do you know what, they can actually just go right there. If that's where the cable wants to sit, then we can leave the USB ports right here. And you can also see that the USB ports are going to be perfectly secure. The posts are entirely on the wood, that's what matters. Doesn't matter if the board overhangs the wood by a little bit, as long as the posts are in place. So I guess I'll just put some glue on, hold it in place for a little bit, let go, and like I did with this board, we'll leave it to dry. All I'm going to do is get some of this double-sided, I say double-sided, I've got this sticky back foam. I'm going to cut a strip out of it. It doesn't even need to be that long either. I'll just cut double the width of the drive, sort of like that. Then I'll cut into here. We're not looking for perfection here, we're just looking for something that's going to hold the SSD. Do it like that. And then the SSD plugs into the board like this, so it goes on here, and then the other one will go on there as well. If I just spin it round. And I am going to design and 3D print a little bracket as well that screws into, you know, that hole and that hole. But in the meantime, I don't want to be putting any pressure on the SATA connector. So that can go like that. This can go right on top. And we can put it in the laptop. Like I say then, low effort. But now it sags just the slightest little bit. So that can be like that, and I'm just going to model something that screws in here, and then there's a matching hole on the other side as well. I've decided just to put the power button here. I'm probably going to end up desoldering this, and then soldering some wires and putting a power button there. But in the meantime, the power button works like this, and I'm going to 3D print a post that can just sit beneath it. This is the sad point at which the project abruptly ends, and I'll explain why. You'll remember I talked about removing the GPU coil and how I've put it back in the meantime. You may also remember I talked about a chip that's beneath the RAM. That chip used to be soldered there, where those pads are. Despite all evidence to the contrary, I decided to desolder it anyway because I thought it would work, and then I'd be able to use a laptop without a GPU. I know now that all the graphics data is sent through the GPU no matter what on Sony laptops where there's a GPU on the board. That's unique to Sony as far as I'm aware, and I've really not worked on many Sony laptops because they aren't terribly common. So the problem is I removed that chip, then I found that information out, then I went to solder it back, only I've lost the chip. I've got absolutely no idea where it's gone. So this project at that point became dead in the water. I did think I'd show you the remaining things that I did though before I realised the project wasn't going to work. So I 3D printed two more posts that were a little bit taller. All I did was measure the gap between, you know, the MDF and this piece. And that's rock solid, it's nice and secure in place, and it would have worked fine. And then for the SSD, I went really low tech. I just 3D printed two slightly adjusted L shapes and then glued them down. Going forwards, if I'd wanted to install Wi-Fi, I guess it would have had to get put here, so this clearly wouldn't have worked, the power button. But realistically, I could have just used a USB Wi-Fi dongle as well in the USB 3 connector that's here, because there's still 3 USB ports there. Or I could have just plugged it in via Ethernet, because there's an Ethernet port up here, and most offices have wired Ethernet. As for sound, I very rarely need sound on a work machine. I mean, at the office, it's just a machine for answering emails or whatever. It's no hardship to plug a speaker into one of these two connectors. Wi-Fi could either go on the board, or you could plug it in here, or you could use Ethernet. Bluetooth, again, could just get plugged in. You can get a dongle for a few pounds. Or even better, you could actually just take the Bluetooth card that came with the laptop and plug it into the motherboard. And of course, let's say down the line I need more storage. I would just take out the 2 screws and the SSD would come straight out. I'll put more storage in. I need to replace a BIOS battery, it's right there. I want to upgrade the processor, okay, fine, take the screws out. I want to upgrade the RAM, it's right there. And then finally, the charging port. I was going to 3D print a little bracket or a cover. Temporarily, I put a drop of super glue on it, again, and just stuck it down, because I knew full well that if I did want to remove it, I would just use a hammer and give it a very gentle tap. It would have snapped straight off, and then I would probably have put it facing this direction. And that's all I should have needed to do, really. I suppose that's that then. It's a little bit sad that this project was a failure, But I mean, you can either look at it as a failure and a complete and utter waste of time when you're an idiot, and why did you even bother doing that? Or you can say, well, actually, now I'm a bit better at 3D modeling. I've pretty much learned that yes, you can indeed use glue to attach plastic to MDF. I was slightly skeptical, but I have gone around and looked, and none of the posts have broken free or anything. The motherboard is perfectly secure. I improved my 3D modeling skills when I designed a little bracket to mount the SSD. I've learned a lot about Sony BIOSes, Sony boards, and so on. I've spent ages reading schematics for a slightly different model, just trying to, trying to see if I could make the thing work. And obviously, in the end, it didn't. But that's all right. You know, I've got knowledge now that I can carry forwards into future paying work. Again, that's the reason why we do jobs like this. Because now, if a customer brings a device to me and it's a Sony laptop and it's not outputting, pretty much straight away I'm going to be able to say, look, it needs a new motherboard, you know, instead of spending the 2 hours, because you can't bill someone, you need to diagnose it yourself, and when you've diagnosed the fault, then you charge them, or should I say, then you quote them for the fix and you go ahead. But if I had to spend the 2 hours diagnosing on a paid customer's machine, only to turn around and say, yeah, actually I can't fix it, then, you know, I've only been paid £30 for the diagnosis and all that time spent. But when it's something I'm doing in my own time, when I'm not under pressure to get the thing done, when it's not a paying customer who, you know, needs a machine back, I can take a lot longer. It's a much more pleasant process and you learn a lot more. And obviously you don't want to be learning on customer devices. You want to be, I guess that's the reason for the diagnosis though, isn't it? You go away, you do the research and you come back to the customer. Just, you would rather have the knowledge in your head for when the customer needs it than have to go out and put the knowledge in there manually. But if I were to take something like this on again, though, I would obviously do slightly more research beforehand instead of literally gluing a board to a bit of wood. And I guess I would also make sure that the motherboard I've got is actually decent and it can be upgraded, because that's a really good board, you know, replaceable processor, replaceable RAM. It's fairly easy to mod, and, you know, if you're happy to use the GPU, then it's even easier to mod. You don't even need to do anything. I don't like the fact that Sony's charging connector is so weird, but I mean, other than that, you can't really go wrong. And for the most part, those machines are incredibly reliable. But if you were going to do something like this yourself, you would look for, I mean, maybe you have a broken laptop in the cupboard, the keyboard doesn't work, or someone smashed the screen, or it won't hold a charge, or, you know, or a combination of those things. You can just take the board out, stick it to a piece of wood, or stick it to something else that you've got, and you can use it as a low-budget PC. And if you were going to buy a laptop for this specifically, you could get one for pennies, because something that won't run Windows 11 is so cheap it's basically worthless these days, especially if it's 10 or more years old. And you'd be surprised just how much power you can get out of such an old machine. You know, even something with, a 5th Gen i5. You can put 8, 12 gigs of RAM in there, put Linux on it, just leave the default Wi-Fi card on the board, plug the antennas in, trail them off somewhere, zip tie them down, and you'll be away. And you'll spend £10, £15 on a fully fledged computer and stick it to the back of a spare monitor you have, and there you are, you're away. So that's all I've got time for today anyway. I'm going to ask that if you did enjoy the video, you found it useful, maybe there's something you've taken away from it, then consider leaving me a like. You're not the idiot who had to sit there and do it wrong and break the thing. I am, okay? So woe is me, I guess. If you somehow found this entertaining, then feel free to hit subscribe, as all these bloody people are always asking you to do. It's free, you can always change your mind and hit unsubscribe later if you decide that actually I don't want to watch this stuff. I think the next video is going to be on the Sleeper PC series. I've not had a huge amount of stuff to actually record recently. I've just been so caught up in getting back to work, and I've had quite a few projects that haven't gone the way I've wanted, or I've gotten halfway through and thought, you know what, this isn't making for good content, or I wouldn't want to sit and watch this myself. So, I'm not going to reinvent the wheel. I do prefer quality over quantity, and so I guess that's so it's a few videos on the Sleeper PC series, and then we'll be off into new, even more exciting ventures, hopefully. But that's all I have time for today, so I'm going to get out of here now, I guess. I will see you later. Take care, and goodbye.